Hello, my name is Michael Harrison, and this is my new YouTube channel. As I said before, I am better dressed. This is my sweater from the 1990s, obviously. I think it's pretty awesome. And also, there will be some actual content in this YouTube video. Okay, first things first, what is this YouTube channel all about? Well, in this description, it's called Secrets of the Universe, and that's pretty much it. So, through stories, geometry, algebra, I'm going to combine bunches of different things that you didn't know were related, hopefully as well as possible. This first lesson ever, we're going to deal with lines and shapes, or magnitude and area, and how they've been dealt with throughout time, including by the ancients and by modern humans, and how they're related to mathematics, physics, even quantum physics. We're going to start in ancient India about 5,000 years ago with something called Vedic geometry, VEDIC. They were some of the greatest geometers in the history of the earth because they only had a couple things to work with. They only had straight edges, it's upside down, and they have what we would commonly refer to as compasses, but they would basically just have sticks and strings or sticks and ropes. So really they could only construct shapes out of straight lines and arc lengths. This is an equilateral triangle. It is the basis of the universe, right down to the flower of life and beyond that. As you can see, how it is constructed is they drew a line here at the bottom. I drew it set 10 centimeters, but it can be drawn in any length. And then with the compass, they drew arc lengths from one side all the way up to the top, and then from the other side as well. And then from there, where the two crossed, they would draw a point and then make the straight lines, and that's how they would construct an equilateral triangle. Now we get to the more philosophical portion of this lesson. Why are areas information and why are magnitudes only signals? Well, I can describe that to you with a thought experiment as follows. Okay, here we go. Either on a piece of paper or just in your head, draw a line. Now, my next question would be, is that a line? And over 99% of you would say yes, because you just asked us to draw a line. But I would say no, that is not a line. What you drew on your paper or in your head is a very thin rectangle with rounded edges. For if it were a true line, it would be infinitely thin and you cannot see it. And if you could not see it, you could not describe it to me. This is ultimately because at the basis of reality, area is information and cannot travel at the speed of light, but signals, being repeating, although they have no pattern, except a repeating pattern, can travel faster than the speed of light. Here's another analogy. Okay, imagine a photon is a caterpillar crawling across the floor as fast as it can, and as fast as it can is the speed of light because it's a photon. But imagine the caterpillar is pretty long, so you can see that little hump that moves across its back as it moves. Now, by definition, if the maximum speed of the caterpillar is the speed of light, that hump will always be moving across its back faster than the caterpillar is moving across the floor. So in this analogy, the hump is moving faster than the speed of light. It's the same way with light. There's other waves in the light called pilot waves, I think, that always move faster than the speed of light. Okay, for this last subject, we're going to talk about how area and information apply to black holes in quantum theory. It's been a somewhat controversial subject in the past, not as much in the past couple decades. Okay, the way most people think about black holes is that they are large stars or neutron stars that got so massive in some way that they imploded upon themselves into a singularity. But black holes can be thought of in an information way as well. And that is because the surface area of all black holes can be thought of little ones and zeros that are in the area of Planck areas. A Planck area is a square of a Planck unit. A Planck unit is the shortest length that can be measured in this universe. So the Planck area is the smallest area that can be measured in this universe, the smallest ones and zeros you can make. And so, in that context, the area of the event horizon of a black hole is the minimum amount of surface area that surrounds a maximum amount of volume. But black holes can also evaporate through a process called Hawking radiation under certain conditions. And when they do evaporate, scientists still do not know whether they evaporate the same information that they brought in or it is recycled. In other words, either black holes recycle information and ultimately destroy information, which violates quantum physics, or over 99% of all the information that's produced in the entire universe is already stuck in black holes. So where did I get all this information? Well, the Vedic geometry stuff you can look up on Wiki or YouTube. If I can figure out the hyperlinks, I will more than likely do that. Again, this is a fledgling YouTube channel. I'm a one-man show. I'm doing my best. So the caterpillar analogy about the speed of light, that I learned from this book. And the black hole stuff, I learned from this book. I'll warn you, this one is more high level. It's very technical, as is some of this channel, as well as the other book. The other book's better, it's thinner. But between those two, that's how I learned pretty much everything I taught you today. Okay, in conclusion, critiques about myself and promises for my next video. First, critiques about myself. Obviously, the lighting sucks. This is my man cave. I'm not very good at this yet. I'm a one-man show, but I'm always looking to get better. It's called progression. Also, I'd like to just point out on a personal note that I'm highly impressed with all of you people that do this for a living and all of my YouTube teachers and whatnot. I have to be honest, I find it insanely difficult to just stare at a green dot and pretend it's making eye contact with people. It is definitely going to be a learned skill. So I learned a bunch of information from you guys. Now I have to learn other stuff. And finally, as promises go, all I can promise is that I will do my best to be much better next time. My content will be much more thought-provoking, and I will be in my full teaching regalia, for a lack of a better term. Thank you all for watching. You have a great day. I'll talk to you later.